Today we're going to solve another problem in Chapter 8 of Fluid Mechanics, the open channel. The problem is, the trapezoidal channel has a bottom width of 6 meters and a side slope of 2 horizontal to 1 vertical. When the depth of flow is 1.2 meters, the flow is 20.40 cubic meter per second. Compute the specific energy and compute the slope of the channel if roughness coefficient is equals to 0.014 and compute the average shearing stress at the boundary. The given values are width is equals to 6 meters with a slope of 2 horizontal is to 1 vertical with a depth of 3 meters and a flow rate of 20.40 cubic meter per second. First, we were going to compute the specific energy. But before we solve for the specific energy, we were going to find the area and velocity of the channel. Area is equals to width multiplied to depth over 2. Plug in the values, we have 10.8 meter plus 6 meter multiplied to 1.2 meter over 2 is equals to 9 meters squared. In finding the velocity, we use the equation area multiplied to velocity. Plug in the values, we have 20.40 cubic meter per second is equals to 9 meters squared multiplied to the velocity. So our velocity is equals to 2.27 meter per second. Now we were going to solve for the specific energy. We were going to use the equation specific energy denoted as E equals the velocity squared over 2 multiplied to acceleration due to gravity added to its depth. Plug in the values, we have specific energy equals to 2.27 meter per second squared over 2 times 9.81 meter per second squared added to 3 meter. We have 5.1529 meter squared per second squared over 19.62 meter per second squared added to 3 meters. Cancel out the units. We have the specific energy equals to 3.2626 meter. Next, the problem asks for the slope of the channel. But before that, we were going to solve for the parameters of the channel and its hydraulic radius. For the parameter, we have 2 times 2.683 meter added to 6 meter. We have 11.366 meter as our perimeter. And for our hydraulic radius, we have area of a parameter. Since the value of our area is 9 meters squared over 11.366 meter. So our hydraulic radius is equals to 0.79. So we were going to solve for the slope of the channel with the equation velocity is equals to hydraulic radius raised to the power 2/3 multiplied to the slope of the channel raised to the power of 1/2 over the roughness coefficient. Then plug in the values, we have 2.27 meter per second is equals to 0.79 2/3 multiplied to s raised to the power of 1/2 over 0.014. So our slope is 0.00138. Lastly, we are going to compute the average shearing stress at the boundary. We use the formula shear stress equals the unit weight of water multiplied to hydraulic radius and the slope. Plug in the values, we have 9.81 kN per cubic meter multiplied to 0.79 meter multiplied to 0.00138 is equals to 0.10694862 kilopascals or 10.69 pascals. So the value of our average shearing stress is equals to 10.69 pascals. That's all for today. Thank you for watching. Multiply to 0.00138.